Welcome to V-Guide TV. In this video, we are giving a quick revision on chapter units and dimensions. Before going for the numericals of units and dimension, first I am giving some basic units and dimensions of some non-quantities. Because if you know these quantities, you can find the dimensions of any physical quantity. So I'll just go through that fast. Mass, the unit of mass is kilogram, SI unit is kilogram and dimension is m. Length, meter, dimension L. Time, second, dimension T. Electric current, ampere, I. Temperature, Kelvin, K. Distance, meter, length. Displacement, meter, L. Speed, distance by time, so it is meter per second. LT minus 1 is the dimension. Velocity, displacement by time, meter per second, LT minus 1. Acceleration, change in velocity by time, meter per second square, LT minus 2. Force, it is MA, F equals MA, kilogram, meter, second minus 2. Its unit is also called Newton and its dimension is MLT minus 2. So remember this dimension. Okay. Force, anytime you should remember force as MA, that is MLT minus 2. MLT minus 2. Now momentum, mass into velocity, that is kilogram, meter, second minus 1, MLT minus 1. We know the mass and speed means you can write directly fast. Area, length into breadth, meter square, L square. Volume, LBH, meter cube, L cube. Density, mass by volume, kilogram, meter power minus 3, ml minus 3. Work, force into displacement, Newton meter, kg, meter square, second minus 2, or joule. It is also called, dimension is ml square t minus 2. Remember, the work and energy should have same unit and same dimension. So if you take the kinetic energy or potential energy, the equations are different but units and dimensions are same as energy. Now, power, work by time. This energy, power, these all very important. Power is work by time, joule per second or watts. Kg, meter square, second minus 3 or ml square t minus 3. Pressure, important. Force by area. Newton, meter power minus 2, Pascal. Okay, it is also called MLT minus 2 by L square. See, with the standard unit only we are doing this. So it will be ML minus 1, T minus 2. These are the dimensions of few quantities. Not all, I am giving only few. This also you just see, I am just going for the current related terms. Charge is IT, that is ampere second. It is also called coulomb. Dimension is IT. Electric potential, work by charge. So joule per coulomb, volt. ml square t minus 2 by IT. It can be written as ml square t minus 3 I minus 1 for electric potential. Resistance R equals V by I. Ohm or volt per ampere. It can also be written as volt, it's there in numerator, divided by one more ampere means in current term one more term is coming. Here it is minus 1 but here it become minus 2. Resistivity, rho equals R A by L. R we got it now. Okay, and remember RA by L means area is meter square, length is meter. So we can written it as ohm meter. It is ml cube. One more L will come. If you compare this with this, ohm is here. With ohm, meter you add it. Meter means one more L. So M, L square become L cubed. T minus 3, I minus 2. Gravitational constant, G, Fr square by M1, M2. So how we write the unit? Newton meter square, kg power minus 2. Because force is Newton, R square is meter square, M1, M2, kg power minus 2. Here also write the dimension. Newton is MLT minus 2. L square by kg square is m square. It goes up m minus 1. L cube. L into L square. L cube T minus 2. Frequency. it is hertz t minus 1. So here I discussed some basic quantities. It means some basic dimensions only. With that dimension, you can find out any dimensions. Okay. Before going for a numerical, you have to remember here what is principle of homogeneity. What is principle of homogeneity? We are writing an equation a plus b equal to c. According to principle of homogeneity, dimension of A should be equal to dimension of B, that should be equal to dimension of C. So this principle is called principle of homogeneity. By using this in dimensional analysis, we can find out an equation, or we can derive an equation, we can check an equation is correct or not. Like that, many applications we can do it. So I told only about the basic things of dimension. Now I am going for the numericals. The dimensions of A by B in the equation P equals A minus T square by Bx, where P is pressure and X is distance and T is time. What is the question? I need to find the dimension of A by B. Okay. They are given an equation. What is the equation? P equals A minus T square by Bx, where A and B are constants. P is pressure. Okay. And T is the time and X is the distance they told. So first I am going to find out the dimension of pressure. What is the dimension of pressure? Force by area. That is the reason I told the tabular column before. Force dimension you should remember. Mass into acceleration. That is mLt minus 2 is the dimension. Divided by area. That is L square. Dimension should put it in the square bracket. Okay. So it is force divided by area. So if you solve this one, L minus 1 T minus 2 is the dimension of pressure. Okay. I got the first step. I got pressure. Now I am using principle of homogeneity. What is your equation? Your equation is P equals A minus T square by Bx is the equation. Just now I told, according to principle of homogeneity, what happens? Each and every term should have same dimension. So I am cross multiplying this equation. Pbx equals A minus T square. Okay. So I did not write that step. You can write Pbx is equal to A minus T square. So I am getting an equation like this. According to homogeneity, dimension of Pbx should be equal to dimension of A. That should be equal to dimension of T square. Okay. So I wrote that. Dimension of Pbx equals dimension of A is equal to dimension of T square. In this, if you see this equation, one you can solve it fast because A and T square are same. It means A is equal to T square. T is the time dimension I told you, capital T. So A equals T square. Equation number 1. Next what I am doing is I am equating the first and the third term. These two I am equating. These two if you are equating, Pbx equals T square or B equals T square by Px. What is T square? Capital T square. What is P? Is ml minus 1 T minus 2 into X, again L. If you see L minus 1 L cancel. This m goes up, so m minus 1. T minus 2 goes up, t to the power of 4. So I got the dimension of B. Understood? T square means time square, capital T square. Pressure, we found it first. Substitute. Into X. What is called X? X is called L. So we are solving. Question is A by B. A is T square by B is m minus 1 T power 4. So it is mt to the power of minus 2 is the dimension. Clear? So what I did? So from this question, you can do any type of questions like this. They are given in the form of equation, means you cross multiply, make it like this. Okay. Then you can tell that each and every term should have same dimension. Apply principle of homogeneity. Clear? Next question. With dimensional analysis, we can find or we can derive a relation. P represents radiation pressure. C represents speed of light. Q represents radiation energy striking a unit area per second. Then x, y, z are non-zero integers that p power x, q power y, c power z is dimensionless. Then find x, y, z. This question is little simple only, direct only, but the answer they gave little tricky. So that's what I gave 4 options. In this 4 option, which is correct, they asked. Okay. So what I'm doing first, they gave many quantities. So I'm just doing P they told. What is P? Pressure. No problem. Just now only we found for pressure. What is the pressure dimension? ml minus 1, T minus 2. We just now found. C we don't have problem because speed of the light. You know what is speed of the light? It is LT minus 1. Next is little tricky, Q. Energy, people won't read full. Energy per unit area per second. What is the meaning? Energy by area by time. So energy is ml square T minus 2 by area is L square and time is T. If you solve this one, we will get mt power minus 3. So when you see the question, that time only you have to just write what are the terms they give. So here the trick is pressure they gave, C they gave, Q they gave. So I have written all 3 at the side first. Pressure is ml minus 1 T minus 2, C is LT minus 1, Q only energy by area by time I did. Okay. After that, the next step is they gave it in the question P, Q, P power X, Q power Y, C power Z are dimensionless. These are dimensionless, they told. What is the meaning of dimensionless? Dimensionless means the dimension is 1. Okay. Very important. What is the meaning of dimensionless? Dimension is 1. So I'm writing that as my first step. P power x, q power y, c power z equals 1. This is given in the question. Clear? You write what they are given. Next step. Already you have written PQC, right? That you substitute in this. P, in place of P write dimension m L minus 1 T minus 2 raised to x. Q, what is Q? mt minus 3 raised to y. Next C, LT minus 1 raised to z is equal to dimensionless, no? So you can write m power 0, L power 0, T power 0. That means equal to 1. I hope you all understood. First, I found the terms. Then I have written the dimension. Then from the question they gave a hint, it is dimensionless. So I have written that. Then I am writing the dimension of each term. Clear? Next term is you have to equate the powers of M, L and T from left side and right side. First I am equating powers of M. See, M is here. What is the power of M here? X. Here also one M. What is the power? Y. Here no M. Here M power 0. So I can write X plus Y equals 0. Can you tell Y plus Y? You learn A power M into A power N is A power M plus N. So powers I am equating X plus Y equals, here what is the power in the right hand side? No term, so it is 0. Next I am equating the powers of L. Powers of L means minus X plus, what is L term here? Z. is equal to 0. Next is equate the power of t. Minus, how many powers are there? Here 1t, here 1t, here also 1t. 3 t's are there. Minus 2x, minus 3y, minus z, minus 2x, minus 3y, minus z is equal to 0. So I got 3 equations. Okay. Normally these type of questions we can solve and find out. But in this question, solving and finding out is coming as difficult. Then after that, what you can do is tricky method of solving. A tricky method of solving means among the 4 options, which one satisfies this condition you check. According to this equation, what is the meaning? X and y, x should be equal to minus y. According to this equation, x and z should be same. So we understood x and z should be same, y should be minus of that. So see here, x and z should be same. First option wrong. Second option you see x equals 1, z equal to 1. They both are same. What about y? Is minus. So which option is correct? X equals 1, y equals minus 1, z equal to 1, because only this option satisfies this situation or this condition. Another method of solving is there. Okay, few other questions how we are solving is after getting the equation by using elimination method or substitution method, find out the value of x, y and z. That is one method. Okay, but we can use a tricky method of analysis that after getting this you check it in this equation satisfies which condition. So from this I got 2 things. X should be equal to minus 5 and x and c are same. X and c are same. From this I understood that second option is correct. So just we'll go to that again. What we did, we found the dimension of all the quantities, then what they are given we have written, we wrote the dimensions, then we are writing the equation by equating the powers of ml and t, then solve it. Next, in dimension, and another main thing you should remember is trigonometric ratio, exponential terms and logarithmic terms, they have no dimension. For example, they are given an equation y equals a sine kx. This equation, this term you see, the term kx is inside the trigonometry. According to me, it has no dimension. So kx should be equal to 1. So what should be the dimension of k? 1 by x, 1 by L. That is L power minus 1, where L is the displacement. In this way, we can find the dimension of trigonometric ratios. Okay, I'll give a question. A student writes 4 equations for a periodic motion. Which are the equation you see? A sine 2 pi t by t, a sine vt, y equals a by t sine t by a, y equals a by root 2 sine 2 pi t, 2 pi t by t plus cos 2 pi t by t, where a is maximum displacement, v is speed and t is the time period. Which are the wrong equations dimensionally? So I should check which equation is wrong. For that only I have written this one, because trigonometric terms have no dimension. And according to principle of homogeneity, we know that left side and right side dimension should be same, right? So I am taking one by one the term. First term I am taking A. Dimension of displacement L, right? Dimension of displacement is L. Dimension of A also L. Trigonometric term I am taking. Trigonometric term should have no dimension. So here you see 2 pi t by t, time by time, that should be equal to 1. So first equation is correct. It is not wrong. It is a correct equation. Second equation, y displacement, dimension. I am writing only the dimension here. Y dimension is L. A dimension also L. Now I am checking for the trigonometry. Trigonometric term is Vt. What is V? Velocity. Lt minus 1. Lt minus 1. Time T. But if you check, I am getting a dimension inside the trigonometry. Inside the trigonometry, I am not getting dimension as 1 here. I am getting a dimension of what I am getting? L. It is wrong. So the second equation is wrong. Okay, second is wrong. One more. Check it, this one. Y is the displacement. A by T. Okay, A we know displacement, amplitude they told. A is the maximum displacement. Okay, so we can write here, remember in this A is the displacement, Y also displacement only. So I can write Y displacement as L, A also displacement L, but denominator 1T. First checking itself, that equation is coming wrong because L is not equal to L by T. So this equation also wrong. See the last equation. Y equals A by root 2. Root 2 has no dimension. This have dimension L. Correct. Now check for the trigonometry. Inside the trigonometry, 2 pi T by T. T by T dimension will be 1. Cos 2 pi T by T dimension will be 1. So this equation also dimensionally correct. So if you see an equation with the trigonometry, exponential or logarithmic terms, no need to worry. Equate that term should be equal to 1. Clear? Equate the term should be equal to 1. So how we are checking whether it is correct or not? Left side dimension should be equal to right side dimension, or each and every term should have same dimension. Now I am going for another main topic of this chapter, that is called error equation. See here, I am giving an equation. Let an equation x equals AB. If they ask error, delta x by x is this formula, you remember, delta A by A plus delta B by B. That is another equation. This is the first equation. Second equation, if x equals A power n, B power m, C power r, like equation in this form, then how the error will change? How the error equation? Delta x by x is power, you should write n delta A by A plus m delta B by B plus r delta C by C. See, the term is in denominator, but I put plus because errors are additive in nature. See the example. The voltage is given as, in a circuit, the voltage is given as 4 plus or minus 0.25 volt. Current is given as 1 plus or minus 0.1 ampere. What is the value of resistance with percentage error? So if you see an equation like this, you remember first one is the voltage value, next one is the error value. This is the first is the current value, next is the error in the current. So I am writing an equation for resistance. First, R equals V by I. V is 4, I is 1. 4 by 1 is 4 ohm. If you want the resistance is delta R by R equals delta V by V plus delta I by I. In this, remember, multiplication and division should have the same rule. So R equals V by I is delta R by R equals delta V by V plus delta I by I. Then delta V is 0.25 by 4 plus 0.1 by 1. So if you solve this, we will get 0.1625. This, if you need in percentage, multiply with 100, that is 16.25. What is the resistance value? R plus or minus 16.25 percentage. So what I did, first I found R, then I found error by using this equation, then I found a percentage error, and we are writing in this form. What is the form? 4 plus or minus 16.25. Next question. The current voltage relation of a diode is I equals e to the power of 1000 V by T minus 1 milliampere, where V is the voltage and T is the temperature in Kelvin. If the student makes an error in measuring 0. plus or minus 0.1 voltage while measuring the current of 5 milliampere at 300 Kelvin, what will be the value of current in 10 milliampere? What will be the error in the value of current in milliampere? How we are doing is, they told the current is 5 milliampere At which Kelvin? 300 Kelvin. And they gave error in the voltage. I am writing the given equation first. I equals e to the power of 1000 V by T minus 1. They gave it in the question. And they gave the current value. So I substituted the current value. If I am taking this minus 1 to the other side, e to the power of 1000 V by T is 6. Okay. Then next is, in this equation, this is the given equation. I equals e to the power of this equation. If you want error, you can differentiate I with respect to V. It means di by dV I am doing. The variation of current with respect to voltage, that is di by dV. That is, we are differentiating e to the power of 2x. E to the power of 2x differential is e to the power of 2x into 2, right? So, e to the power of 1000 V by T into 1000 by T. So, what is di? It is 1000 by T e to the power of 1000 V by T into dV. 1000 by T into, what is this one? 6 into dV. What is dV? 0.1 volt. So, 60 by T. That is 60 by 300. Clear? What we are doing? 1000 by T is here. dV 1000 V by T e to the power of 1000 V by T is, what is the value we got from equation number 1? 6. Into dV is this value. What is dV? 0.1. 0.01. So we'll get 60 by T, that is 60 by 300, that is 0.2 milliampere. Very important question. Many times they ask. They gave an equation. From that equation, you find the exponential term. That is the first step. After that, given equation, you write differentiate. When you differentiate, we get a term like this. They are asking what is the error in the value of current. So I need di, cross multiply. When you cross multiply, this term value you substitute. So we will get it as 0.2 milliampere. Now, a simple question, that is, what is the dimension of half epsilon 0 e square? I am telling a shortcut for this. If you know what is this equation, no need of writing dimensions. Okay, because this you remember, this is for energy density of a capacitor. This is the energy density of a capacitor. What is energy density of a capacitor? That is energy by volume. Energy dimension you know, ml square T minus 2. By volume is L cube. That's what in the first slide I told. If you know the standard one, you can do any dimension. So ml square T minus 2 by L cube. That is ml minus 1 T minus 2. Same like that, one more term is there. I think you know that B square by 2 mu naught is the magnetic energy density. Is called magnetic energy density. These equations are very simple to remember. Okay. Half epsilon 0 E square for electric energy density. B square by 2 mu naught by magnetic energy density. I got it. Now, another simple question from this chapter they can ask is, if the error in the measurement of radius of sphere is 2%, what is the error in the determination of volume? So we can take here, they are given here, the error in the measurement of radius of sphere is 2%. What is the error in the volume? So we can take here, percentage of radius is 2%. Then you write the volume equation, 4 by 3 pi r cubed. Delta V by V percentage is 3 into delta R by R percentage. That is 3 into 2. What we are doing, you understood? I am taking the percentage error of this. 4 by 3 is a 4 by 3 pi is constant, no variation. So it is proportional to V proportional to R cube. Applying the formula, delta V by V is N into delta A by A. That is delta V by V equals 3 into delta R by R percentage. Delta R by R we know 2%. So it will be equal to 2%. 3 into 2. Answer is 6%. Thank you. Subscribe for more videos for VGuide TV. Thank you.